What would it take to exterminate life on Earth? To kill every living thing? And turn the entire world into a barren wasteland? 250 million years ago, it nearly happened. The result of a volcanic apocalypse unlike any ever recorded in history. Our planet, a bastion of life in a cold, dark universe, nearly dies, with only a few species left to start all over again. This is the worst catastrophe life on Earth has ever endured. Who will survive the great dying on Animal Armageddon? Diseased nature oftentimes breaks forth in strange eruptions. William Shakespeare, 1598. A 250 million years ago, in a time known as the Permian, the world we know didn't exist. In fact, the world of dinosaurs didn't even exist. This is millions of years before they appeared on Earth. All land is fused together into one supercontinent called Pangaea. This place, the cradle of life for over 150 million years, is on the verge of collapse.
It's important to understand that the end Permian extinction event was the nearest life came to complete annihilation. With a little bit more of a push, we would not be here, nothing would be here.
But for now though, Pangaea is a tropical paradise filled with lush conifer forests, refreshing streams, and exotic creatures like something out of science fiction. Their shapes are as foreign as their names. Lystrosaurus, Gorgonopsian, Thrinaxodon, and Dicynodon. They are the mammal-like reptiles.
Mammal-like reptiles are kind of the lost group of vertebrates, lost in the fact that they've never had their own popular movie. They're not mammals because they have differences in their bone structure. They may or may not have been warm-blooded, but we think they were. They may or may not have had live birth, although we think they may have done that too.
Theirs is a bizarre and little-known dynasty, almost entirely severed from the animal kingdom we know today.
Let's imagine now the African plain, Kenya, and you see vast herds of beasts. They would look like mammals from a distance. Wildebeests. You get up closer and you see, no, these aren't true mammals at all. They're mammal-like reptiles.
At the end of the Permian period, this forgotten world is flourishing. Earth is a place of peace and prosperity. A reptilian Garden of Eden.
The world was a lot simpler then because we're used to thinking of different animals on each continent, but in the Permian, everybody lived everywhere. You find the same creatures on land in different parts from north to south.
The warm, shallow ocean that covers the rest of the planet is also swarming with life. How could such a nurturing world become so hostile that 90% of all animals on land and sea will vanish forever? "60 miles beneath the Earth's crust, the answer is brewing." Superheated magma, welling up for thousands of years, has created a pressure cooker that's on the verge of exploding. But Pangea inhabitants are blissfully unaware of what's about to happen. All across what is now Kansas, flocks of Lystrosaurus graze the plains. These hog-sized creatures have sharp beaks for pruning plant life, and long tusks and claws for digging up roots and tubers. Oblivious that doomsday is coming, they go about their lives focused on more immediate dangers. The greatest comes from Gorgonopsian, king of the Permian jungle.
All right, let's bring a Gorgonopsian back to life. But if I'm going to do this, I'm going to have him in a cage right there. You need more than a shark cage. This is a big, powerful animal.
They must have been the top predators of their ecosystem. I've seen skulls of these things that are about 2.5 feet long, so much larger than a lion skull today.
A solitary predator, Gorgon can weigh as much as a grizzly bear. A pair of 4-inch canines protrudes from his jaw, the first saber teeth in history. Lystrosauruses are so abundant, they've become a mainstay of the Gorgon's diet. Much like the wildebeest to the African lion. Gorgon is an expert hunter, but a poor butcher.
Gorgonopsians have big, sort of slashing and biting teeth, but they don't really have don't appear to have a whole lot of jaw musculature.
Of course, lions and wolves are mammals. We all have multiple muscles and flexible jaws that we can move back and forwards, side to side. The Gorgonopsians were classic reptiles. The jaws just snap shut, open and shut.
Like an alligator, Gorgon clamps down, but he can only shear off one piece of meat. With food so easy to find, this isn't a problem. There will be plenty more targets available the next time he's hungry. With Gorgon long gone, a meek but hungry Thrinaxodon slinks in. This cat-sized carnivore lives on scavenged meat and insects while dwelling in the shadows. But this scavenger's survival will be crucial to our own future.
Thrinaxodon seems to give rise to all subsequent groups that become modern mammals. If Thrinaxodon doesn't get through this mass extinction, we don't have this conversation. Maybe something else is here, but not us.
Who will be equipped to survive the coming apocalypse? In just 5 hours, the test will begin. Across the supercontinent in what is now Siberia, volcanic pressure is coming to a head. Building beneath an evergreen forest filled with life. Today, the search for food has led Lystrosaurus and the closely related Dicynodons to a strange and ominous discovery. Whatever it is, it exhales foul, sulfurous breath, a witch's brew of toxic chemicals unlike anything these creatures have experienced before. Unaware of the danger, they probe the hardened black soil.
It's very hard to know what it would have felt like in the last days of the Permian. Certainly if you'd been near to the Siberian traps, there must have been premonitions of something about to happen.
Suddenly, violent tremors rip their way through the forest. The Great Dying, the worst mass extinction the world has ever known, has begun. Molten basalt rock, an ocean of liquid death, roars from 60 miles below the surface. A 20-mile crack severs the landscape. The Earth is literally splitting apart. Animals are incinerated in a flash, like paper in a flame, consumed by a tidal wave of liquid fire. So fast and profuse is the lava flow, it could cover all of New York State in 48 hours. And still the surge keeps coming. The worst catastrophe in Earth history is off to a terrifying start. The air is filled with the fearful wailing of thousands of animals. In time, all the creatures of the world will join this sad chorus. The worst mass extinction in the history of life on Earth has begun. Hundreds of thousands have already been lost in Siberia, but it will be billions worldwide before this is over. One year after the first eruptions, lava continues to ooze. Today, scientists refer to this volcanic episode as the Siberian Traps event.
Most volcanoes blow their top and then stop. Short-term volcanic activity and long periods in between. But these Siberian traps, these flood basalts, didn't play by the rules. They kept spewing and spewing and spewing, and now 100 years, 1,000 years, 10,000 years.
Volcanoes typically erupt from a single finite pocket of magma, but the Siberian traps are endlessly restocked through a series of pipelines from a sea of liquid rock churning below.
Because humans have never seen a real flood basalt eruption, I think we can only imagine what it's like to have thousands of years of lava just welling out of cracks in the earth.
In our time, with the continents split apart, this type of eruption might only cause a local disaster. But at this time, with the continents joined, the chain reaction can't be contained. Wounded, hungry, and confused, the survivors begin a mass exodus from Siberia. With so many animals completely vulnerable, the Gorgons are thriving for now. As the Great Dying drags on, with months becoming years, it will become crystal clear that there is nowhere to run, that no creature will escape their fate. The volcano's wrath slowly overcomes the world, throwing Mother Earth off balance. Years pass. Volcanic gases build up in the atmosphere, driving the next wave of the disaster, lethal climate change. The cracks in the Earth release gigatons of carbon dioxide and sulfur dioxide into the air. Sulfur dioxide blocks out the sun, while carbon dioxide traps heat. The increase of both gases triggers decades of intense, seesawing weather patterns.
The climate is disrupted by the initial volcanic eruptions, which cause global cooling because of the dust and the sulfur dioxide, and then probably warming as CO2 begins to build up in the atmosphere. So you have sort of a mix of things, and climates are probably switching back and forth. That makes it pretty hard for animals to figure out how to live.
Even here, in what is now South Africa, 15,000 miles from the Siberian traps, a pall of doom is in the air. The sudden change in the climate creates a whole new challenge for those still living: breathing.
The whole world would have started feeling this because global warming, carbon dioxide doesn't stay in one spot. All this CO2 is going up into the atmosphere in Siberia. The CO2 rapidly disperses all over the globe. So as CO2 increases in percentage over Siberia, so too does it globally.
Not only do temperatures worldwide go up by a few critical degrees, oxygen levels start going down. The Lystrosaurus and Gorgons have no idea what's happening to them. But suddenly, it's getting harder and harder to breathe. Their primitive reptilian respiratory systems simply aren't equipped to handle the thinning air. The hunter and hunted now share the same struggle to survive. Still, it's the little Thrinaxodon that perseveres. Seems like evolution is favoring the ultimate underdog in this crisis. Her small, thin frame makes her better suited to the heat than the bigger players of this lost world, and the bony plate separating her nose from her mouth, a distinctly mammalian trait, enables the Thrinaxodon to breathe and chew at the same time. As the air turns foul, it's a critical adaptation, and it's something the larger, stronger mammal-like reptiles are missing. Another advantage this little species has is its social structure. Like many of today's small mammals, Thrinaxodon lives in a supportive group of family and neighbors.
This animal was denning. It probably had young in that den. It might have even had a communal structure, sort of like a meerkat with multiple individuals living in sort of a community structure. And that's really a hallmark of sort of mammal type of behavior.
Especially in times of stress, communal living can ease the burden of staying fed or fending off predators. But Thrinaxodon is not the only creature to weather the storm so far. A new predator is thriving in the rapidly warming environment. Proterosuchus.
The nasties of the late Permian and the early Triassic are a group called archosaurs. The meanest, nastiest, and first of them is called Proterosuchus.
Proterosuchus is not a dinosaur, but in time his kind will give rise to them.
It would have looked very much like a crocodile, except a crocodile with legs, not splayed out to the side, but underneath it. His head is up on a neck. It's got a skull that's sort of crocodilian, but a little more compressed to the side.
It was a predator. It may have been aquatic, it may have lived in water and hunted fish and grabbed animals on the bank of the stream. That's a good kind of adaptation, and it was able to be opportunistic.
Being cold-blooded means Proterosuchus uses the sun's energy to regulate his body temperature. The hotter it gets, the better he seems to feel.
We would like to think that warm-bloodedness is a great thing. We're warm-blooded, crocodiles ain't. But when the world was a lot warmer than it is today, you're probably well off being cold-blooded, because one of the big differences is that we need to eat 10 times as much as a crocodile eats. It costs us a lot to be warm-blooded, so Proterosuchus and the archosaurs that evolved from it had a great advantage. They didn't need to find so much food.
It's been 25 years since the first eruptions of the Siberian traps. And still the molten basalt continues to flow. Hardening into pitch-black mountains where nothing can grow. The animals that inhabited the region have been forced out. Like a herd of lost buffalo, the Dicynodons wander endlessly, always on the lookout for an elusive safe haven. The Gorgons of northern Asia have seen their population cut by half due to hunger and disease. The younger generation knows nothing of their ancestors' glory days, just this meager, desperate existence. And there is no relief. More punishment is about to strike from above. Acid rain. The next stage of the disaster is brewing in the atmosphere itself. Volcanic sulfur dioxide combines with water vapor to create sulfuric acid. Now even the rain has the power to kill.
The downwind consequences would have been a lot like living near a really bad Eastern European coal generating plant. I mean, it just would have been an awful place to live.
You see these pictures where acid rain has just killed whole forests, and you have pine trees standing which have turned brown and the leaves are falling. If that's continuing over a long span of time, as probably happened in Siberia, acid rain would kill all of the plant life.
Day in and day out, the caustic liquid rains down on every corner of the globe, killing all the vegetation. And for those with no place to hide, daily life becomes excruciating. Only our ancestor, little Thranaxodon, is small enough to find shelter from the storm. Will Thranaxodon be the only survivor? In what is now the Arizona desert, a tropical floodplain offers little escape from the oppressive conditions. The once majestic forests of conifers, the ancestors of today's evergreens, are dying by the millions. Plant life withers in the stifling heat. With vegetation the foundation of the food chain, starvation now runs rampant. Hardest hit are the large herbivores like Dicynodon. Their bulging abdomens mask an intricate cluster of digestive organs that process the coarse roughage on which they subsist.
These sorts of things. They were largely low nutrition kinds of plants, so the plant eaters would have had to work hard. They would have been eating all day, probably.
Now the Dicynodon's food sources are literally drying up, and new generations aren't adapting fast enough to deal with the growing famine. Their numbers dwindle, but so do the others that feed upon them.
We need to understand there's a food chain operating so that the extinction of plants will affect everything, all the animals, whether they eat plants or not. And the sequence is, if you kill the plants, you lose all or most of the plant eaters. Therefore, you lose all or most of the flesh eaters because they have nothing to eat.
The Gorgons witness their largest food supply simply vanish before their eyes. Where once there was more than enough food to go around, now there's competition for even the smallest prey.
So you've got fewer herbivores. It takes a lot of herbivores, a big territory, to keep a top carnivore alive and happy. As you reduce the food of the herbivores, as there are fewer and fewer of them, they can support fewer and fewer of the Gorgons.
Their primitive reptilian jaw structure was never a problem when food was so abundant. But now, their inability to properly tear a carcass apart is costing them dearly. The Gorgons are starving to death. It's 200 years since the extinction began. Earth keeps inching closer to complete destruction. It's a time of unprecedented annihilation, a depth of devastation never experienced before or since. One predator rises to power, Proterosuchus. The high temperatures are a boon to this cold-blooded creature.
There are times in Earth history when it's better to be a cold blood than a warm blood. If we have a world where it's already warm anyway and it never gets cold at night, I mean, this is a great place to be a cold-blooded animal. You need less energy.
Our ancient ancestor, Thrinaxodon, is also fated for survival. Being a tiny scavenger, she has no problems living on morsels of food that nobody else wants.
Now you have all the insects in the world. You have dead meat that's out here. You have small reptiles. You have amphibians. You have a lot of food sources available to you. When you're a very big top carnivore, that's not the case.
Thrinaxodon embodies tenacity. Where other creatures might give up in the face of such harsh conditions, she fights every day to keep herself and her offspring fed and protected. Perhaps it's her proto-mammalian instincts that drive her. Whatever it is, the future of all mammals, including mankind, depends on her unrelenting will to live. Thrinaxodon wouldn't look much like any mammal alive today. But scientists believe that this small creature was a direct ancestor to modern mammals, including the human race. So how do we know that Thrinaxodon was related to mammals, including mankind? Evidence of its unique mammalian traits comes from the fossil record.
Yeah.
Its spinal column suggests it had a diaphragm,
There's sand in
and its snout had holes that suggest it may have had whiskers. If it had whiskers, it probably had hair, and if it had hair, it was most certainly warm-blooded. As more clues are uncovered, science will shed even more light on our ancient ancestors and their evolution. "10,000 years have passed since the Siberian traps first erupted. What started in an isolated region of northern Asia has now engulfed the whole planet. Life on Earth is on the precipice of complete extinction. Everywhere in Pangaea, the vegetation is dead and rotting. And when the summer monsoons strike, flash floods wash much of it out to sea. Along with millions of tons of topsoil. The influx of so much waste is turning the seas into a cesspool, and global warming is causing even more damage.
If you're warm everywhere on the planet, nothing drives air, nothing drives the oceans. At the end of the Permian then, we've heated the planet to the point that ocean currents stop. Once they stop, you start losing oxygen. Warm water holds less oxygen than cold water. And once oceans lose oxygen, you start killing things.
As the sea loses oxygen, life is smothered.
We've got good evidence of this stagnation of the oceans, that when you look at the rock record, you can see before the event there are abundant reefs with all kinds of life and creatures burrowing in the seabed and all the rest of it. After the crisis, the rocks go black. This is evidence that of the oceans had become poor in oxygen, they'd become stagnant.
There's no group of animals or plants that's unaffected. Many of the groups which had dominated ecosystems in the oceans for hundreds of millions of years disappeared. They're gone.
The ocean floor is littered with the remains of the dead. Only bacteria remains.
As the ocean changed from oxygen to oxygen-free, the microbial content changed from the friendly microbes, which are sort of life-neutral to us, to a totally different group. This different group produces hydrogen sulfide. Hydrogen sulfide is a very toxic gas. If we start increasing it into the atmosphere, you can kill off land life, and this really seems to be what happened.
The hydrogen sulfide acts like a chemical weapon. Winds circulate the poison gas worldwide. Animals are killed in great swathes. But one creature proves resistant to these lethal clouds. Reptiles like Proterosuchus may have been immune to the effects of this toxic gas.
A new experiment's taking place by Mark Roth of the Fred Hutchinson Cancer Institute in Seattle has been showing that a reptile can survive a much higher level of hydrogen sulfide than a mammal can. It turns out that cold-bloodedness protects you against the H2S, the hydrogen sulfide.
And so it is time to take on the king of the jungle. A weary Gorgon approaches the watering hole. Just a few generations ago, Gorgon would have had the size and weight advantage in this match. Not anymore. Now the noxious environment has left him vulnerable. His kind is rapidly vanishing throughout the globe. It's now the ambitious Proterosuchus whose star is on the rise. He smells victory and his next meal. Proterosuchus and others like him are becoming top carnivores. It is now 20,000 years into the Great Dying. Death on land drives death in the ocean. Death in the ocean drives death on land. As this vicious cycle intensifies, the planet lurches toward oblivion. Does anyone, even Proterosuchus, have a future? The valley was full of bones, and lo, they were very dry. Ezekiel chapter 37, verse 1. 150,000 years after the Great Dying began, The Siberian lava flow that launched the greatest mass extinction ever known on planet Earth is now a mile deep, enough to encase 4 Empire State Buildings stacked one on top of another. For as far as the eye can see, there is only eerie silence. The lush forests gone. The refreshing streams gone. The herds that once populated this fertile landscape, all gone.
From space, there's no green, there's no plants, there's just this huge landscape of rock.
From this wound at Ground Zero in Siberia, death has spread around the world. Once giant herds of Lystrosaurus were ubiquitous. Now, only a lucky few persevere. Only staying on the move in an endless migration will keep them one step ahead of death. Millennia of hardship have seen the Lystrosaurus evolve into survivors. Now it's only the hardiest of the species that remain. They are smaller than their ancestors. They can go longer without food and water. And their survival instincts are razor sharp. Here in what is now Egypt, this band of migrating Lystrosaurus find a hidden treasure. Any fresh water in this arid desert world is worth fighting for. But this little stream won't just quench their thirst. It's about to change the destiny of their species and the history of life on Earth. Because another herd has been drawn to this very spring, a band of Lystrosaurus from South Africa. Both groups have evolved along parallel tracks, adapting to desert conditions, lower oxygen, foul air, and scarce food. Interbreeding will make this species even tougher. A new generation, with the best genes from both families, will survive the great dying. Still, the future of this species will depend on adaptation and chance.
There's a question of luck and design happening at two levels. They were lucky to survive, but then the ones that went on to rebuild the ecosystems, they also had good adaptations that fitted them to the future. So people need to separate those two aspects. How do you get through the crisis, and then what do you do afterwards?
Their cousins, the Dicynodons, haven't been as lucky. The rapidly changing world is too much for the species to bear. This is their only legacy. Sadly, the former master has come to a somber end. The last Gorgons die alone, diseased and starving. The proud, ferocious line of the Gorgonopsian is now extinct, never to return. "500,000 years after it began, the great dying draws to a close. The Siberian traps poured over 2.5 million square miles of lava onto the Earth's surface. Enough black basalt to cover over 3/4 of the US several miles deep. Between 90 and 95% of life on Earth has perished, and the kingdom of the mammal-like reptiles is lost forever. It is the worst mass extinction in Earth's entire history.
There's no ecosystem on Earth that's unaffected. There's no group of animals or plants that's unaffected. The end permanent extinction is about twice as severe as any other mass extinction that we have in the last 600 million years.
But as a testament to how resilient life really is, even this was not enough to drive all animals into extinction. Can these hardy few rebuild what has been lost? It was not death, for I stood up, and all the dead lie down. Emily Dickinson, 1862. $1.2 million years after a killer volcanic episode nearly strangled the entire planet to death, only the faintest flicker of life remains.
Each of those species that survived was probably driven down to just a tiny little castaway surviving population. So those survivors were lucky in a sense, but they had a pretty grim time for a long time afterwards as the Earth recovered.
And from just a handful of survivors, evolution begins anew. But life's comeback won't be an easy journey. The world they've inherited is hostile when compared to the tropical wonderland of the Permian period.
As we study the early Triassic, 5 million years or so after this event, it took an awful long time before life even began to get better. So there's a long interval after this extinction where most groups of animals are just getting by.
The Lystrosaurus survived the apocalypse to inherit this new world. Their species has seen a dramatic transformation.
There's a big difference in the size of the Lystrosaurus between the Permian and the Triassic. Permian animals were doing really well, and they tended to be large, and whatever killed them going through that boundary knocked down the largest ones, and so the largest ones disappeared, but then the remainders was also on average smaller.
Another survivor, Proterosuchus, had been a bit player before the Permian extinction. Never more than 2 to 3% of Earth's population. Now, with the big warm bloods like Gorgon missing, they take over the hunter-killer niche.
Proterosuchus then led to, and there was the evolution of, a variety of archosaurs, which ultimately led to modern crocodiles on the one hand and modern birds on the other hand. In between, of course, we had the dinosaurs.
Luckily for us, our ancestor, Little Thranaxodon, has also made it through the extinction.
Thranaxodon is a key animal because now, looking back, that was nearest to our ancestor of all the survivors.
Thranaxodon had the right stuff at the right time to ensure not only its own survival, but the future of all mammals, including the human race. For us, the story of the Great Dying has a happy ending. But it's also a cautionary tale. Earth could rage again at any time. Unleashing a slow, relentless stranglehold on our planet. The key question for us is, Would we have the right stuff to survive a mass extinction? Or like the once mighty Gorgons, would evolution leave us in the dust?